Okay, so this next section is called vertex form of a quadratic equation. Some people kind of looked this up earlier in the chapter when we were talking about writing a quadratic equation. But this is vertex form. So standard form is what we've been working with. Standard form is ax squared plus bx plus c equals 0, or equals y, if you want to say, if we're talking about a function. Vertex form looks like this. Y equals a times x minus h squared plus k. Why is it so important? Why is it called vertex form? Because we can tell the vertex by just looking at it. So if you have it in this form, then h and k are your vertex. So this is your h, this is your k. That means your axis of symmetry is still the x coordinate of the vertex. So now it's just x equals h. And just like before, A still does the same thing. A stretches or shrinks your graph. And also if A is positive, then that means your parabola is going to open up. And if A is negative, that means that your parabola is going to open down. Why won't that move? I swear this smartboard hates me. And so what does this mean for us? If something is in vertex form, it means we can graph it much easier, and it means we can find the vertex a lot easier. So remember that our transformations, if a number is added or subtracted inside the function, so x minus h squared, inside the squared part, that's going to be a horizontal translation. So that means that it's going to move it to the left or to the right, just moves the vertex x coordinate. The k value is your vertical translation, so that moves your graph up and down. So if k is positive, it moves it up. If k is negative, it moves it down. Basically, it just switches the vertex. Also remember what a does to our graph, right? If a is negative, that's why it opens down, because it reflects over the x-axis. And remember that a also stretches or shrinks our graph, or this book calls it a dilation. If a is between 0 and 1, like a fraction, it's going to make our graph wider. And if a is bigger than 1, it's going to make it thinner. It's going to stretch it vertically, which means that we should be able to graph these a lot simpler if they're in vertex form. So let me show you what I mean by that. So it says graph each equation. Remember, when we graphed before, we had to find the vertex first, negative b over 2a. But now we don't have to. If you think about y equals a times x minus h squared plus k, our vertex is at hk. So in this case, h is 3, because notice the formula is minus h. And plus k means that our k value on this one, because that's a minus, would be negative 4. So right away, just by looking at it, I can tell the vertex. A is the number in front here, and there's nothing in front, which means A is 1, which means that it hasn't changed at all. So on this first one, I'm going to graph both graphs just to remind us. So I'm going to graph y equals x squared as like our parent graph, just to remind you really quick about this. So x squared, remember, starts at 0, 0, and then we do our 1, 3, 5 rule. So we can go over 1, up 1 on each side, over 2, up 4, and over 3, over 1 up 1, over 1 up 3, over 1 up 5. 1, 2, 3, 4, 5. Oh, I missed it. And that gives us our parent graph, right? That is y equals x squared. You don't have to graph that every time, but I just want to show you on this first one what we're actually doing when we translate this. What does this minus 3 mean? That means that it moved right 3. And what does this minus 4 mean? It means it moved down 4. So it's basically like I'm taking this vertex right here, and I'm just moving it over 1, 2, 3, down 1, 2, 3, 4. And that, I don't know why it switched colors on me. Goodness gracious, would be my new vertex. And then we can do the same thing. We can go over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5. And I get the graph very quickly without having to do a bunch of work like negative b over 2a and plugging it back in. Okay? So that's why vertex form is fantastic. So let's do another one. What about this one? Well, first of all, we want to think about what the vertex is. So this one, remember, it's hk, where it's x minus h squared plus k. So because the formula is plus k, this is always the sign that goes with this. So like this is 3. But because this is minus h, you have to always take the opposite sign. Or think about the only way this minus could turn into a plus is if that was a negative 1. So it's always the opposite sign of what's inside the parentheses and the same sign that's out here. So what does that mean? That actually means that it's moved left 1 and up 3, right? We're taking our vertex and moving it over. What does the 2 mean out front? That means it's stretched by a factor of 2, right? So you can make an XY chart if you want. But what I'm going to do, I'm going to make my vertex at negative 1, 1, 2, 3. And then normally I would go my 1, 3, 5 rule, right? But I'm multiplying by 2. So that just means I'm also going to multiply all these by 2, which means now I'm going to go up over 1 up 2, over 1 up 6, over 1 up 10. So if I go over 1, I'm now going to go up twice as fast. If I went over 1 again, I would go 1, 2, 3, 4, 5, 6, which would actually go off my graph. That would be up there at 11. So what you should see when there's a number in front like that, it's going to change my graph and make it thinner. Look how much less work I have to do when I graph that, which is why I'm a big fan of vertex form. But what if it's not in vertex form? And if it's not in vertex form, that means we have to put it in vertex form. And that's partly where our completing the square can come into play, because we have to take something that's not a perfect square and make it a perfect square. So think about this. We want this to look like a times x minus h squared plus k. So we want to take this thing that's not a perfect square and make it a perfect square. So what we can do is we can complete the square. But it's a little bit different than when we're solving it. Let me show you what I mean by that. So this plus 2, normally we subtract over here, but it's not 0 anymore, it's y, and we have to keep y by itself. So what I do when I'm completing the square, I'm still going to leave my spot to complete the square, but I'm just going to kick this 2 out to the end and make it plus 2 out here. And then I'm going to complete the square like I normally do. I'm going to take half of 6, which is 3, and I'm going to square it, which means I would put a plus 9 here. But think about what we normally do. When we solve the equation, I add 9 here, and I'd add 9 over here. But am I allowed to add 9 over there with y? And the answer is no. I want y to be by itself. So instead of adding 9 over here, what could I do on the same side that would keep it balanced? So normally I add 9 to both sides of the equal sign. But instead, if I add 9 here, what would I do out here? Well, I would just subtract 9, because adding 9 and then subtracting 9 keeps it all balanced. So look what I've just done. I could now factor this into what multiplies to give me 9 that adds to give me 6 would be 3 and 3. And then 2 minus 9 is negative 7. So by looking at this, I can see that the vertex is what? Negative 3, negative 7. Which means it's going to move left 3 and down 7. It still has an a value of 1, so I would just do 1, 3, 5 rule. Now I do want to show you there's another way to do this, all right? I'm a big fan of completing the square. I think that it works really nice. It kind of makes you practice this idea. But what if you just use the standard form? How did we find the vertex up until this point if it was in standard form? Well, remember that we could find the x-coordinate of the vertex by just doing negative b over 2a. So we could still do that here. We could do negative 6 over 2 times a, which is 1. And I would get x equals negative 3. And then how do we find the y-coordinate of the vertex? Well, we have to plug it back in, right? So we would do y equals negative 3 squared plus 6 times negative 3 plus 2. So that would be 9 minus 18 plus 2, or negative 9 plus 2 is 7. So I still get my vertex to be negative 3, 7, doing it the old way. But if it says put it in vertex form, you have to be able to take this HK and put it into this form. And so you might say, well, how do I know what A is? Well, A is just whatever A is up here, right? So A is still just 1. So you can take this HK here, and you can say y equals 1A x minus negative 3 squared plus 7. Minus 7, minus 7. Right? So it's the same thing to do. It's just your choice. The completing the square way is the new way. That's the old way. Lots of people struggled with that before. Okay? So I think I have one more. Yep. So I want you to see where you can get with this. Put this in vertex form. Do it whichever method that you want, and then we'll check that in class tomorrow.